Have you ever noticed those straight lines in walls, in floors, on curbs along roads? They're always so straight, so neat, almost like someone drew them there. But at the same time, they look like cracks, and cracks usually mean one thing: something went wrong, right? But here's what doesn't make sense. If this was damage, why does it look so controlled? Why does it appear in the same places over and over and over again, across different buildings, different roads, different cities? It's almost like it's not random at all. So what's really going on here? Here's something a lot of people don't realize. Buildings and structures don't stay still. They are constantly moving, not in a way you can see, but in a way that absolutely matters. When the temperature goes up, materials expand. When it cools down, they shrink. And this doesn't happen once in a while. It happens every single day. A wall sitting in the sun will expand slightly and then shrink again when it cools down at night. The same thing happens with concrete, steel, tiles, everything. Now, on something small, you'd never notice it, but when that movement happens across a long wall or a large floor or an entire road, it starts to build up. And when it builds up, things start pushing against each other. And here's the part that matters. The movement itself is not the problem. The problem is when that movement has nowhere to go. So what actually happens when that movement has nowhere to go? It doesn't just disappear. It builds up until something gives. And when it does, it's usually messy, random, and completely uncontrolled. That's why sometimes you see tiles suddenly lift out of the floor, or cracks forming in walls in places you didn't expect, or surfaces that looked perfectly fine suddenly failing. It's not always because the construction was poor. It's often because the movement had nowhere to go, and you can actually see a simple version of this. If I hold this piece of aluminum foil above a candle flame, watch what happens. The foil starts to move. It bends, it twists, it reacts. Not because it's burning, but because heat is making it expand. And as it tries to expand, different parts of the foil move differently, causing the whole thing to deform and shift. Now, imagine that happening across an entire concrete floor or a long wall or a bridge deck. The structure wants to move, but something is restraining it. And when a structure tries to move but can't, stress starts building up inside the material itself. That stress keeps increasing until eventually something cracks, lifts, bends, or fails. Not because the structure burned, but because it was trying to move while something was stopping it from moving. And that's the key idea. If you don't control that movement, the structure will find its own way to release it. So instead of trying to stop this movement, engineers do something much smarter. They take control of it. Instead of letting the structure crack randomly, they decide exactly where that movement or that crack is allowed to happen. And they do that by introducing what we call joints. These are the straight lines you see in walls, in floors, and even on roads. They're not there because something went wrong. They're there to make sure that things don't go wrong. They create small gaps or weak points in very specific locations so that when the building or the structure expands or shrinks, that movement is absorbed safely. Instead of pressure building up across the entire structure, it gets released exactly where it's supposed to. So that crack you're seeing isn't damage at all. It's actually protection. Now, here's where it gets a bit more interesting. Not all of these joints are doing the same job. They might look similar, but they're solving different problems. For example, if you look at tiles in a large floor, you'll sometimes see slightly wider gaps filled with a flexible material. That gap is there to allow movement, so the tiles can expand without pushing against each other. Then, if you look at a concrete slab, like a pavement or a warehouse floor, you'll often see thin, straight lines cut into the surface. Those aren't random. They're there to guide where the cracks will form. So instead of cracking everywhere, it cracks in a straight, controlled line. And then you get larger joints, like the ones you see on bridges, where there's actually a gap between sections. That's there to allow much bigger movement, especially with temperature changes. So even though all of these look like simple lines or gaps, each one is doing something very different. And once you see that, you start to realize that these aren't signs of damage at all. They're part of the design. Have you ever noticed a long wall with a straight vertical line running through it? Not a messy crack, but a clean, almost perfect line. At first glance, it looks like damage, but in many cases, that line is there for the same reason. As that wall expands and contracts, or even shifts slightly over time, the movement builds up along its length, and instead of cracking randomly across the surface, the structure releases that movement along a straight line. So what looks like a crack is actually the wall relieving pressure in a controlled way. It's the same idea, just on a different part of the structure. And once you start noticing it, you'll realize these lines show up again and again, but in different buildings, in different places, all doing the same thing. Hi everyone, the South African engineer here. If this explanation was useful, please like the video, subscribe, and turn on your notifications. Every subscription is a brick used to build the Engineering Explained house. Let's build this house together. Thank you for watching.